Good afternoon, everyone. In the today's class of this machine tools and machine cutting, we would like to discuss regarding the new subtopic in the unit number 4, that is thread cutting process. Basically, this thread cutting process is one of the phenomena indeed to hold tightly the nut and bolt, indeed to have a tightening of the screws with respect to the another subcomponent over the basic component, indeed to confide the statistical movements or statistical permanent fixation for the object. We are having these threadings that are convenient for happening both internally as well as the externally. Here externally in the sense for the studs, in order to hold the nut and bolt alignment will be getting progressed, and screwing helps us to tighten directly with respect to the material. So internally in the sense, the best example of this bolt, nut and bolt. For the nut, there will be an internal threading, bolt will be an external threading, and on and combination, that will be having a fixed alignment. That we will be discussing very much clearly in the next slides. Coming to the different types of methods that we are having for the thread production. Coming to the production of this screw thread, it is subclassified into 3 groups. First one is upon casting process, we'll be having the threading. Upon rolling process, we are having the threading. And upon the machining process, we are having the cuttings, threadings. In the casting process, sand die, permanent mold, plastic molding, shell molding, last wax. This will be utilized for having the consigned impregnation, and the molten metal will be poured into the mold so that the threading will be getting obtained. In the case of this rolling process, a flat dies and circular dies will be utilized for having these thread cuttings. This machining is subclassified into 2 groups. One, it is cutting process, and second one, it is the grinding process. Coming to this grinding process, we are having traverse grinding and plunge grinding for getting the threading activity over the materials. Confiding to the cutting process, it is again subclassified into 2 groups. That is, the threading is obtained by removing the material or the flat material, flat cylindrical obtaining material, and remove the material over that objects indeed to get the threading shapes. So this will be normally obtained by a single point cutting tool and multi-point cutting tools. The single point cutting tool is normally obtained in the case of this lathe machining process, and in the case of this multi-point cutting tool, tapping, die heads, chasing, milling, and broaching process. Let's have a detailed look regarding the classifications one by one. Casting and molding process, there is a basic initial process. In this process, the threads that are obtained directly as per the geometrical specifications as impregnations created in the mold, or will be having a standard die which will be made up of standard materials, that is stainless steel or cast iron. And upon pouring the molten metal in the die, after getting solidified, the material will be obtained with respect to the particular shapes, and it can be removed, and finishing will be getting done at the output axis. And mainly here, the accuracy and finish, that is depending upon the type of casting process that we have been utilized during the working methods. And if at all the finishing has not been obtained in a particular desired level, the machining process helps to get the perfect finish and the desired precision levels of dimensions. But it leads to minimal economical in ratio that increases with respect to the cost than the expected cost. And we are having another one more supporting method in the case of this casting and molding, that sand casting process. Normally, it's a least preference of uses that which is utilized rarely in the case of this non-precision machinery. Coming to the limitations, is nothing but it can be overcome by a shell molding process also. But actually, in the case of this casting or molding, lost wax method will produce the high accurate threads, that too with good finishing in the materials. But in the economical point of view, it is very much high in ratio, and even it is some of the typical task for having the work commencement. Even some of the threads that are manufacturing or producing with respect to the permanent mold castings, as we have been discussed, that the dye is a permanent material, that's also will be having an equivalent with respect to the wax process. Nothing but accuracy will be maintained and high surface finishing will be getting achieved. Normally, this die casting is applicable only for low melting points. Nothing but where the low melting points will be achieved for which kind of materials, particularly in the case of non-ferrous content of metals. Nothing but without any iron mixture, the materials which are existing, such as lead, tin, aluminium, magnesium, titanium, these are the non-ferrous content of metals. Therefore, these are particularly not utilized repeatedly due to its less strength and less durability. Majorly, the application of this plastic molded threads, that too in the plastic bottles, and die cast threads is capable regarding this glands, which will be generally calling as these connectors or fittings. Nothing but even best example is our water bottle. You need to tighten the cap over the bottle mouth. So threading is made for cap, the internal threading, and for the bottle, which is manufactured in the case of this blow molding, that the external part will be die casted. Nothing but as per the shape of the standard die, it will be getting obtained. Coming to the point of this thread rolling process. Actually, these are formed into blank by pressing threading die against the blank. So almost the threading dies will be existing. See, these are the threading dies, and these dies will be pressing or compressing action will be getting considered in between the two threading dies, and the material will be passed over it, and upon its compression or application of these forces against the blank, that used to have the same impregnations that used to penetrate over the blank material. Nominally, that material is displayed from the bottom of the thread and having the thread crust. So the cold working process is processed the deformation of the material plastically, that is permanent changing of its dimensions with the help of the pair of dies. Nothing but cold working process in the sense the machining process, or else the either of the compression or else the tensile process, nothing but extinction processes that are being commenced during the normal atmospheric range of temperature without increasing in temperature or else decreasing in temperature. So normal atmosphere, the work that is being done for shaping the materials or transforming the materials plastically upon the load implication of them on the materials, that use it to change its dimensions from one phase to another phase in a permanent cadre, that is plastic deformation in the sense permanently the deformations dimensions will be getting changed. So that is called the cold working process. Actually, we are having four different types of thread rolling machines. First one, it is the reciprocating or flat die machines, cylindrical die machines, rotatory planetary machine, selector die machines. Coming to the reciprocating flat die machines, coming to the flat dies, here one die is fixed, that is nothing but the bottom die, as clearly specifies in the diagram, that is stationary die, and other one it is a moving parallel, that is nothing but reciprocating die, will be called as reciprocating die, that moves over the other die by the material placed in between. So how this will be getting happened, reciprocation. In a horizontal mode, its most convenient and common method utilized for this flat die condition. In the vertical mode, it occupies very much less space and lubrication under the gravity with respect to the cleaning process. Third one is the inclined level. It derives the benefit for both horizontal and vertical features. Nominally, almost all these flat dies made of this hardened cold die steel, the material that is cold die steel, and provides the threads like grooves of the geometry that are up to a desired thread limitations. Nominally, the blank is placed on the stationary die, and then the moving die will slides over the blank die. Nothing but the blank. Because of those kinds of actions, that blank that will be having or that will be rolled between the two dies and threads are formed over the blank. Coming to the case of the cylindrical thread rolling machines. See, in the pictorial representation, it is very much clear that two identical circle dies with a parallel axis that are rotated in the same direction and speed. See, this same direction, considering it's a counterclockwise, it's just counterclockwise. But one of the die will be staying fixed. See here, it is fixed. And other die will move radially, that too at a desirable depth of the thread that need to be obtained for the material. So desired depth in the sense up to a particular feed conditions will be maintained in the machining process. Coming to the roll machine of another guy, there is one die is moved radially outward, is radially outward, clockwise, clockwise, and clockwise. So three roll dice. Similar operations will be getting progressed. One will be moving the outwards, and blank will be entering between the die and closes. And later on, the rolls will be getting happened with the same orientations of the speed equally that used to penetrate the threadings or the middle materials up to a particular depth or thickness that need to be obtained. The rotatory or planetary thread rolling machine is typically looks like this. It's the die, then stationary die segment, and this is the loading point. Nothing but the depth of cut, that depth of penetration should be processed, and this is the loading points. Nominally, in this case, that is the rotatory planetary machine, the job that is rolled between the center die, which rotates continuously about the fixed axis. So the shaft will be fixed permanently, and at a fixed axis, the orientation will be getting considered. That is nothing but rotating actions will be continuously processed. Moreover, concave shaped die segment that is located adjacent to the periphery of the rotating die. So it will be acting as a periphery, nothing but in the concave shapes. And even this action will be getting done in predefined way and very much fast in the method of thread rolling. Next one is the sector circular die threading rolling. See here the object or blanks will be getting fed to it, and normally central rolling die is and permanent fixed here, and this rolling activity will be getting done, and this the stationary die will be existing there itself, and the material will be entering over here, the blanks, and the threading will be getting done up to a particular impregnation. See, this is the depth that will be getting conferred over the materials, and after getting machined, the product will be getting out. And actually, this is the simplest form of this threading process. So, coming to the advantages, so how much for whether it is capable or not. So, if at all it is has been happened, whether it is capable to a maximum constraint or not. Coming to the basic advantages, the grain fibers that remain continuous and follow the contours of the threaded surface. By this, the threads are less easily shed off than the machined threads. See here we have a detailed point. Due to the continuous flow of these fibers and contours, it is less easily sheared off and meshed than the machined threads. Particularly during this thread rolling, the material is strained plastically, and even it is work hardened, that leads very much strong against the both this tension and fatigue. So repeated load and the tension created by the application of the force. Hence, the surface of this rolled thread is harder than the cut thread. Hence, water resistance will be getting increased upon this coefficient of friction. Another one more advantage it is surface finishing is very much better as it controls by the rolling process. Even this dimensional accuracy is also better as it is very little whir occurs on the rolls as it progresses over the cutting tool. Basically, it's a faster in production. No any skilled labor is required for operating this. This is chipless. There's no any wastage of the material that is getting removed during the machining process. But it is very much economical and requires very simple machine tools and simple machines also. Coming to the limitations, the disadvantages towards the thread rolling process is applicable for the threads of smaller diameters, shorter lengths, that too for the shorter lengths, and having the finer pitch levels. By this, it cannot provide that much of high accuracy. Basically, it is applicable for relatively softer metals, which are used mostly for making the external screw threads. Need the separate dies for different threads. Coming to an thread cutting on machinery ranges. Initially, will be looking after over the lathe machine working process. The HSS material is used for the tool part, or if at all any hardest materials or finest hard materials should be utilized, then the cemented carbide tools will be placing a major role. Normally, the center lathes to single spindle automats are used as a cutting tools. Normally, in the case of the special purpose lathes and computer numerical controlled lathes, the turning centers will be used. That gives the better accuracy over the work parts upon the machining conditions or machining operations. And hence, on the center lathes, the threads are produced by different methods. In that, the first method, that is by single point cutting tool, by the thread chasing, nothing but covered later, that we'll be seeing in the further slides. What is meant by chasing? And the third one, it is by attachments of die threading and tapping method. That's also will be looking furtherly. Coming to the cutting with a single point tool over the lathe machine. A single tool which is fixed in the tool post, that is monitored over the work part which is fixed in the chunk, particularly a cylindrical object or conical objects which is fixed within the chunks, and this tool is moved across the workpiece that too linearly for about a particular length. And here the chipping process, that too for a wide range, that is chip off the workpiece, will be getting progressed. That too for confined lengths, particular areas, particular lengths. Here in this condition, the operator who is performing the actual process should have the conservant with different terms and with different types of threads, where the starts are required and what is the shapes that are need to be achieved, as maybe ACME ACMA shapes, or particularly a triangle shape of threads and square threads, vice versa. Particularly here, the external and internal threads are cut on the lathe machine, which will help for the die. That is used nominally in the conditional ways of manufacturing methods. Here, the work tool is moved over the job at which we need to have a threading that will be getting engaged with respect to the lead screw. nothing but when the half nut will be engaged with respect to the lead screw. Because the tool should ground to the proper shape in order to get the exact profile of the thread that should be processed when the during the machining process. Nothing but the cutting should be getting done in order to have the perfect profile. And even different lathes provide a quick change of gearbox with different aspects, different spindle speeds, that helps the different pitch levels of the threads over the work part to be monitored. So actually this gear shiftings increases the depth of the thread cutting or decreases the depth of thread cutting, and having the continuity of its shapes, either it may be acme shape or is the square shape or triangular shape, etc. Nominally, over the lathe machine, if the threadings need to be performed, in the sense, a spindle will be connected to the lead screw, that too with the help of the gears, and you to have the positive carriage as a feed to be obtained and driven at a particular speed with respect to the spindle. Speed is maintained as it clearly specifies. This is the lead screw, is the driven, this is the driver that will be getting made over the rotating consignment with respect to the spindle, and the tool will be getting an engagement of remove the small chips from the work part by having a particular thread cutting process. Nominally, the driving of a bed is considered upon the screw thread with the help of the lead screw, which is acting as a basic gear train that is being arranged as shown in the following. That is a simple gear train that we can characterize as the turns of the lead screw by turns of the spindle. Particularly, we will be calling as an teeth on driver by teeth on driven. And hence, this is an ideal gear that will be utilized for having its a rotation as we'll say that the intermediate gear that is having no effect on its ratio. It's just a filling up of gap between the driver and the driven, which is called a driven gear, and possible of making this lead screw to rotate in the same direction of the spindle speed or spindle rotation. Second thing, it is compound gear train. Nominally, driver and driven gear ratio becomes very much difficult in the selection of gears for the arrangement of in a simple train that leads to an difficult in its setting of the gears. Nominally, in that cases of compound wheel train, the ratio will be becoming as the turns of lead screw by turns of the spindle. Nothing but the teeth on C by teeth on D into teeth on E by teeth on F, as specifies clearly in the gear linkage alignments between the driver or spindle gear to the lead screw gear, and this is the ideal gear that is acting as connectivity for transferring of the power from the driver to the driven shaft. Particularly, this range between 20 to 120 teeth in step, that too with 240s or 260s. Nominally, we'll be having this lead screws within made up of almost the single threaded, and even the pitch will be getting varying from 5 to 10 mm, particularly depending upon its size of the machinery. Seeing one of the best example, calculation of the suitable gear trains for the following cases. There is 2.5 mm pitch on 6 mm lead screw. There is a first condition. 11 TPA turns per inch on a 4 turns per inch lead screw. 7 threads in 10 mm on 6 mm lead screw. 7 by 22 inch pitch 3 start on the lathe with 2 turns per inch. 2.5 mm pitch or a 4 turns per inch lead screw, and 12 turns per inch on a lathe having 6 mm pitch lead screw. So calculating this, we are having the nominal formula as an initial case. 2.5 mm pitch on 6 mm lead screw. So here the drivers is 2.5 and driven is 6 mm. So 2.5 by 6, and changing its float value to the nominal value, normal value, polynomial value 5 by 12 is equal to 25 by 60. So even it can calculate with respect to float value also. Nothing but 25 teeth driving 60 teeth in a simple train. Simultaneously, this 11 turns per inch on a 4 turns per inch lead screw. There is 1 by 11 by 1 by 4, leads chain 4 by 11, weights 2 into 5 multiplications 20 by 55, leads chain confidity of 40 by 110. We can calculate it as 20 by 55 for our convenience, or else an linear value, that is both the even values 40 by 110. Very simple gear train. And third one, it is 7 threads in 10 mm on 6 mm lead screw. Here the pitch is 10 by 7. So hence that will be the driver's point of view. Hence 10 by 7 by 6. 10 by 42. 6 7 is 42. That is 5 into 2 by 7 by 6. That is 50 by 70 into 20 by 60. Nothing but a compound train with 50 teeth. That is nothing but having 50 teeth and 20 teeth as drivers, and 70 and 60 teeth as a driven state of conditions. And simultaneously having calculated same turns per inch calculations, where this, in the case of these drivers and drivens, the normal calculations are confided with following examples. Thank you. We'll meeting in the next class.